and welcome to this video on functions. I'd just like to add a quick reminder that make sure you have watched the previous videos because the concepts that we are going to be using here will require them. Alright, so without wasting any further time, let's see why do we need functions and how do we actually go about using them. Okay, so let's say all we had was a requirement that you will be given a side length of a square and you need to print its area. So most of you might be familiar that the area of a square is just side into side. All right, just the product of length and breadth, and because length and breadth are numerically equal, so you just return the square of this. So you could do something like this, for example, let's say you could say side is equal to 4 and you could just print out side into side, right? Now this will also work. This is a working piece of code, but it is not very usable because what if you had to use this small piece of code inside of a larger piece of code so that this code could live on its own, right? Maybe that didn't make much sense. So I'll go ahead and break down each and every line individually. First, what we want is a separate name for a bunch of code that basically just takes an input, in this case the side length, and just does some processing on that. We want to give it a separate name, all right? We want this section of code to live independently on its own, all right? So we will just call this function as area, all right? So things to notice: def, this is a keyword, def. You have to use that whenever you want to define a function, all right, which is followed by, you have to give a space, all right? Space is a must. You can give more than one space as well, but I think it just looks better if you have just one space. And after that follows the name of the function. In this case, it's area. Again, try to make these names context sensitive. For example, you could do with some x, y, z as well, but I think it's better to have context sensitive names. So the name of a function is area, and after this comes the parentheses, and the parentheses takes what are called the arguments, all right? Or you can think of them as inputs. So what all values does our function need? Well, it needs to know the side length, right, to be able to calculate the area. So we need to pass that. We can call it side, all right? The variable can be referred to by any name. You can call it L, S, anything that you want. But let's say this function area will get the argument called side. So what it needs to print is basically just side into side. Okay, so you can just say print side times side, and that will actually print out the area, right? All right, so now you might say, okay, but how do we actually call this function? So calling the function is as simple as, first of all, let's say you want to call area, and then you need to provide this input, which is side, all right, which the function declared in its definition. You need to provide that whenever you're calling the function. Well, let's see, if I run this now, we will get an error, which would be a type error, area missing one required positional argument side. So it means you need to provide that. So let's just provide, let's say the side is 23, so the square area should come out to be 529, all right? And yeah, similarly what we could do is wrap this thing so that this function, instead of just printing out, actually even returns something, all right? So as of now what we are doing is printing side into side. Let's say we go ahead and instead of printing the value out, we use this an inbuilt functionality called return. We want to return this side into side. So if we run this now, the code will not break, but there will be no output, because what is happening is area of 23, this is like a variable now, all right? So you can think of it as answer is equal to area of 23. Area is called with this input 23, and answer gets assigned to that. Okay, so now you go to actually go ahead and manually print answer out. When you print this answer, now you will get 529 again, right? So what is the advantage of using returns instead of just printing out? Well, the thing is, you can use the return value of one function in another function. You can do function chaining. You can do some sort of a logic based upon what is the value that the one function returned. For example, in this case, let's just say that if the function returns an area which is more than 1000, we are going to print that this is a big square. Otherwise, we'll print, this is a reasonable square. So what should we say? If answer is greater than 1000, we're just defining 1000 as sort of a big number. So if answer is greater than 1000, we would like to print out the square is big. All right. Else, remember the if else syntax from the conditionals video. Else you have to print out the square is usual. All right. So there are only two types of squares that we are having, big and usual. If we go ahead and run this now, the output will be the square is usual because the area will come out to be only 529, right? Let's just put 32 over here, which is the smallest square to actually know its square is the smallest to exceed 1000. So we will get the square is big. All right. So I hope you have been able to understand what was covered here. Again, if you want to watch this video slowly, make sure that you understand this because functions are going to be used in the next videos and in your Python journey ahead. So thank you all. I hope you enjoyed it. Thank you.